Welcome back from the break that you just have. I hope you were able to stretch your legs so that you can continue with our lesson today. Last time when we went for the break, we were talking about the alkanes. So let me just remind you what you have done before. We looked at the alkanes and how you give the name of the structures of the alkanes and take into consideration the rules that you must follow. And then we also did some drawing. How, when you are given the name, how do you draw the structural formula? Now we are going to look at the alkene. And we said the alkene from our table there, it contains the double bond. There must be a double bond between one of the two carbons. Then you cannot have an alkene for the carbon, for only one carbon, because the double bond has to be between two carbons. So let us continue with the rules and see how we name the compounds that belongs to this homologous series, the alkene. We said first you have to check the longest chain, and this longest chain needs to have a double bond. And then that will be the parent name. And then this parent name, remember you must also check how many carbons are there on the parent name. And then it will end with the suffix ene. If it has two carbons, it will be ethene. If it is 3 carbons, it will be propene, 4 carbons, and so on. So before we go any further, remember the table that we were doing before we got to the break. Let us go back to it and try and complete it using only this column. And then the last column you'll be able to do it yourself. So let us look at the structure where we've got 3 carbons. We said with 3 carbons, let's see how the structure would look like. Okay, the structure will look like this. You'll have carbon number 1 there, carbon number 2 with a double bond, and carbon number 3. So you'll see when we look at the second step for naming the compound, they say here you must number your carbon atom in the parent name. You begin at the end nearer to the double bond, and then you give the number of the position of your double bond, where you put the double bond. Okay, so let's see this one. If I number it from this, I'll have 1, 2, 3. So the name of this one will be prop. At carbon, after carbon number 1, I've got a double bond, which is ene. All right. If I change and put it this side, I'll have 1 double bond, 2, 3. So if I number it, I must number it from the side nearer to the double bond. So I'll have 1, 2, 3. So it doesn't matter whether the double bond is this side or it's that side, the name will still be the same, propene. And then let's check if we've got 4 carbons. 4 carbons, we have 1, 2, 3. Let's put the double bond there and carbon number 4. I won't put the hydrogens, but you must remember not to leave out the hydrogens. And then you must also remember that when you put the hydrogens, you must count the number of bonds that we have around 1 carbon. Like this one already you've got 2, so this one only needs 2 bonds. So we have only 2 hydrogens there because those 2 are there. And then this one has 1, 2, 3, and then only need 1 hydrogen for this second carbon. And then the last carbon will have 3 hydrogens around it. So be careful about the number of bonds that you have around 1 carbon, because sometimes you are doing the mistake of putting more than enough bonds around 1 carbon. So just be careful about that one. So this one, we are going to number it from the side nearer to the double bond, and that is this side, because that side is far from the double bond. 1, 2, 3, 4. Let me draw another structure where I've got, I'm going to put the double bond there, where I will have 1, 2, 3, 4. Or I can count from this side, 1, 2, 3, 4. So after carbon number 2 or after carbon number 2, I have a double bond. So the names here are not going to be the same. even though this, we've got 4 carbons, we know that it should be built for 4 carbons. This one is also built. But then if I look at the first structure that I have there, after carbon number 1, I've got a double bond, E-N-E. But this one, after carbon number 2, I've got a double bond, E-N-E. So these are my isomers for the alkene. So for the alkene, if you need to do an isomer, what you do is you move the position of your double bond. If I move it from there to there, these are 2 different structures. But if I look at the number of carbons and hydrogens, they will be the same. So the molecular formula is the same, but the structural formula is different. So these are my isomers for the alkene. So just be careful when you complete the table that you can have here propene, but here you can have build 1 in, or we can have build 2 in. And then we have shown you with the structure the difference between build 1 in and build 2 in. All right. So you must also check the pent, that how many isomers can you form using the pentene, 5 carbons, 6 carbons, 7 carbons, and 8 carbons. So you have all the numbers there so that you know when you look at the position of your double bond, it will tell you which one compound or the name of the compound is the correct one. So this is how you name the alkane, following the rules that we had. You said you begin numbering from the end nearer to the double bond. So you check where the double bond is, and then the double bond must have a lower number. And then this number you must indicate. You must indicate the position of your double bond by this way, that after carbon number 2, I've got a double bond. After carbon number 1, I've got a double bond. So there's my carbon number 1. After it, I've got a double bond. So there it is, the position of my double bond. And then this one, after carbon number 2, I've got a double bond. Or if I go from this way, after carbon number 2, I've got a double bond, and then that will be the name of this compound, build 2 in. All right?